I don't know about that, Dave. I don't know about
He keeps
that.
his smarts in his eyes.
But I appreciate the compliment. That's nice of you. All right, let's rock today.
His bones are intelligent.
So I think I preface this by saying, of everything we've done so far, this might be which section? I won't say the hardest, but it probably will be up till now. But look, I'm going to tell you right now, you've got to know these. Okay, this is going to be very important. All right. There are so many core concepts in here that we've got to pay attention to. And these are going to be the kind of core concepts that are in the notes today that you're going to want to revisit when we start looking at assignment work when we get back from break. Okay. But the title of today's notes is the following. It's titled Trig Functions of what, kids?
Any angle.
Any angle. Now keep in mind, angles are measured two ways for us now. One that we're used to is what?
Degrees.
Degrees. The one that's new for us is radians. And you're going to get better with that with more practice, okay? I think that right now radians are kind of a new concept for you. But as we continue to work through the trimester, that will make more sense as we progress. So here's our question that we need to answer today. How can you use unit circle, okay? This is going to start showing up a lot. And eventually we'll start looking at a unit circle and get a unit circle of values here. Well, how do you use a unit circle to define the trig functions of any angle? Okay. Now, guys, I want you to make note of this. Anytime they use this phrase, unit circle, there is one key rule that comes with this. Okay. There's an assumption to be made here. If you're ever using a unit circle, then your radius on that circle will equal a value of 1. Okay? So if they ever use the phrase unit circle, your automatic assumption is that the radius is what value?
1.
1. Okay? All right, we'll talk more about what this unit circle is here, but if you see the phrase, the radius has to be how long for a unit circle? 1 unit. Okay. So goals to help us answer this question today. How do we use that unit circle to define angles of any trig function? We've got to be able to evaluate trig functions of any angle, all right? We've done a lot of evaluating of trig functions so far, so that should be okay. And then we're going to find and use what's known as reference angles, okay? For some reason, this seems to be difficult for kids, and I'm not really sure why, okay? I'm going to try and give you a little shortcut to this to make sure you understand that. But guys, a reference angle basically is how far the terminal side is from the x-axis. And we'll show you what that means here in a bit. Okay? All right, friends, let's talk. You need to know what a unit circle is. Okay? Unit circle comes from the following. It's the circle that is, what's it say, kids? X squared plus y squared is equal to what?
1.
Okay, now basic general formula for any circle is x minus h squared. You don't really need to write this down unless you want to. Y minus k squared equals r squared. Okay? Okay, h and k are going to represent the center of a circle. All right? I'm not sure, depending on which class you were in last year, I'm not sure you actually covered that last year or not. Okay? That would have been a third trimester concept. Point being is this, if like h was 4 and k was 6, the center of the circle would be at 4 comma 6. Okay? Do you guys see like an x minus any value here in parentheses? So that would be the same as x minus how much?
0.
0. Okay, do you see a y minus anything in parentheses here? No. So this would be like y minus what? And that is why the center for this form right here is where? 0, 0. And then guys, that's going to equal r squared by definition for any circle. Well guys, what number squared is going to make 1? And that's why my radius is what value? 1. Okay? So a unit circle is a circle that's centered at the origin, and the radius is how much to all these points out here? 1 unit. Okay? Are you okay with that? Okay. We're going to have some new angles that are formed today. They're called quadrantal angles. Okay? A quadrantal angle simply is an angle in standard position with the terminal side on a what? Okay, so it would be like this one right here. They use, I'm going to highlight this better. Give me a second. So what a quadrantal angle is this. Okay, here's your initial side. It simply says that your terminal side is on one of the axes, so it's on either this angle. So really, guys, your quadrantal angles are going to be multiples of how many degrees? What kind of angles formed there? 90, okay? So this theta right here, do you really agree it's a counterclockwise rotation of 270 degrees? So quadrantal angles are going to be 90, 180, 270, and so on, okay? Or I can go down to negative 90, negative 180, all right? But basically, this terminal side either ends up on the x-axis or the y-axis, you bet, okay? All right, my friends, let's talk reference angle. I don't know why this is difficult for kids. I've never understood this, okay? And I'm going to talk about this a little differently, okay? I'm just going to write this down. Think of reference angles as this. Just say, how far away is the terminal side away from the x-axis, okay? Reference angles are always going to be compared to the x-axis. So let me give you an example here, okay? The definition technically says a reference angle is the acute angle formed by the, which side? Terminal side of an angle and the what? Okay, you want to take the shortest distance possible for the x-axis, all right? So think of this. You guys see this original angle right here of negative 240 degrees? Okay. If I followed this around from the x down to the y, that'd be negative 90, wouldn't it? Negative 180. And then up here to 240, negative 240. This lands in the third quadrant. So the question becomes, the second quadrant is where this lands. Quadrant number 2 up here. Question becomes, how far is this terminal side away from the x-axis? In other words, what's the angle formed between the terminal side and the x-axis then down here? It says 60 degrees. Okay, so let me give you, well, we'll do some here, but just quickly, let me give you a chance at this. 140 degrees is your angle. Okay? Reference angle. Okay? Kids, where's 140 degrees going to land? First, second, third, or fourth quadrant? Okay, here's 90. And how much more?
A little bit more.
Out there?
Yeah.
Okay, quick question. So this is 140 degrees going around here, right?
40 more.
Okay, do you guys agree that the reference angle I'm looking for is right here?
Yeah.
Well, how many degrees to get down to that x-axis from the terminal side?
40.
So a reference angle for 140 degrees will be what? Okay, depending on which quadrant you're away, if you're in here and only a quadrant away, I could be right close up here and all the way down. Reference angles must always be between 0 and 90 degrees. Good. Reference angles must always be between, oh, I didn't want to do that. Why did I do that?
If it's 90, it would just be 90 both ways. It would have 2.
Yeah, in fact, it would be 0 degrees if it was a reference angle for that. Okay, because if it was like 180,
Yeah.
180 would be
That
0
is-
degrees away. Now, if it was like 90 degrees,
Yeah, 90 or 270.
then it would be 90 degrees away from the x-axis.
Okay.
Okay, so it's either going to range from 0 to, reference angles have to range from, what to what, kids?
0 to 90.
Must range from 0 to I'm also going to write this down here as well. Or 0 radians to pi over 2 radians. Okay? Because 90 degrees is pi over 2 radians. Hey. They'll never be negative.
What if you have them in like the first and third quadrant?
Well, we're only talking about one angle at a time. Okay, and the assumption is one side is going to be in standard position here. The initial side will still be on the positive x-axis, okay? So we're only caring about this terminal side, where that lands. We only care about this side right here and how far away that is from the next axis.
But like, what if, I don't know.
Are you asking if it ends in the third quadrant?
Yeah.
Like
yeah,
this down
yeah.
here?
It's on the bottom, you would still just make it.
Okay, let's just
positive.
say that this was, I don't know, negative, well, here, I'll go this way.
Yeah.
What if this was 230 degrees around that one? Okay, so how far would I have to back up to get here?
Oh,
50 degrees, right?
okay. But it can't be negative.
No, your reference angle would be 50 degrees. And we're going to talk about that idea of plus and minuses and one of the core concepts and make sure that we can compare that. So let's, you're asking great questions here, and I'm going to show you how to get around that, okay? Sound good? Okay. All right. Are we good on the first page vocab wise? All right. All right, well, let's take a look at page 2. First core concept is up here, kids. Okay. Take a look and read that as I read this and read along with me. It says up here, let theta be an angle where, kids?
Standard position.
Okay, so my initial array is over here on the positive x-axis. I've got a terminal side in the second quadrant. It says let x and y be a point on the terminal side of what?
Theta.
Theta. Now keep in mind, what circle are we talking about here?
Standard.
Okay. Kids, right here, this distance from center out, this will be considered my radius r, but in a unit circle, r is going to be what value?
1.
Okay. So, it says the trick is this. It says the 6 trigonometric functions of theta are defined as shown. Sine of theta would equal 1 over what, kids? Okay, this point x comma y is right here. Think about this. If this is an angle down here that the triangle's forming, okay, you know, theta's kind of down here. Angle theta is always going to be relative to the origin. Guys, what's the opposite leg to the angle here in that triangle it forms? What's the distance here? Is that an x distance or a y distance? Vertical, so it's a y distance, right? This would be the radius, and this would be the x distance, wouldn't it?
Yeah.
Okay, so I'm just going to put a little x down here on this triangle like this. This is a y distance. Horizontal distances for a triangle formed in a unit circle are going to be left and right is an x, up and down is a y. Then this distance right here is going to be your radius r. So the hypotenuse is always going to be your what? Radius. Okay? So your rules are this. The sine is equal to y over r. Well, if this is my triangle it forms right here, my angle central to the origin, what's the opposite leg? What's the hypotenuse? Therefore, the definition of sine on this right here is 1 over what? Okay, and all these rules are right here. Think about tangent. Opposite leg, y over adjacent leg of what?
1. Yeah.
X. Now keep in mind, your reference angle for the triangle that forms here is going to be right down here at the origin. Okay? And then your cosine would be the adjacent leg x or r. And then guys, secant, cotangent, those would all just be the reciprocal of them, right? So we've talked about that before. So let's talk about this next example. This is a good one. Friends, help me out here. It says, let what point be
8 negative
the
6.
terminal side of an angle theta in a standard position?
8.
So here we go. Let's talk, kids. First of all, I'm going to draw a coordinate plane. Guys, if I had to ask you to describe to me how to get to the point 8, negative 6, what would you tell me to do?
Graph it.
Or right 8 down.
Right 8 and down 6. So let's do that. So we're going to go right 8 units and down 6. So negative 6 might be right about here. Okay? And what we end up doing is say, okay, that point is in which of our 4 quadrants? Okay, but what we do is from the origin, kids, we draw a segment out to that point, like that. And we're going to form a triangle on the x-axis with it. That is a right triangle. Okay? So here's the deal. Theta is going to be central to the origin, or the angle formed at the origin. So I'm going to call this angle in here theta, right there. Okay? Kids, what's the distance up here? 8. What's this distance really over here?
6.
Okay, and furthermore, since it falls down below the x-axis, we should probably call that what? Not positive 6, but
Oh,
you okay with that?
this is where the online was hard.
Okay, so this is where your positive and negatives are going to start coming into play right here. Okay? Guys, is there any way to figure out the length of the hypotenuse?
Yeah.
Now here's what I'm going to tell you. The hypotenuse is always going to be positive. every single time. Radius will be positive every single time. Okay? What's 8 squared?
64.
Bank that number. What's negative 6 squared? Bank that with your 64. Where are you? So root 100 would be, so the hypotenuse to this has to be how much? Friends, let's talk. Once I've got that established right there, my angle theta in standard form or standard position is established. What do we have to evaluate?
6.
Let's roll. We're going to do the sine of theta, the cosine of theta, and the tangent of theta. And once I establish those three, what should be really easy after that?
The other one.
The other ones, because they're simply the reciprocal. Okay? So relative here, kids. Sine of theta. Theta being an angle relative to the origin. Negative 6 over 10, which I can reduce to what? Negative 3/5, couldn't I? What's opposite of theta, kids? Negative 6 over the hypotenuse? 10. Okay, so what's this force the cosecant to be, kids? Okay, so now I'm going to leave the negative up top. All right, anytime you have negatives for fractions, I say just leave the negative up top all the time. It's just a lot easier to keep it there. So it'll just be negative 5/3. Negative 3/5 and negative 5/3. There you go. What's cosine here, friends? So x over r, or this is like the x value, isn't it, right here?
Yeah.
8 over what? 10, which would reduce to 4/5. So what's that force the secant of theta to be? You guys tell me about the tangent then. Tangent says y over x, doesn't it? Or you could think of tangent as still the opposite leg over the what? Okay. Isn't this the y value right here? 6 is the y, isn't it? Isn't 8 the x value? So if I look at the core concept there, y over x, I could still think opposite leg over adjacent leg again, couldn't I? What over what, friends? Okay, negative 3/4 is what it would reduce to. So my cotangent would be negative 4/3. Kids, when you get a problem like this, when I say, here's your point, I strongly encourage you to draw a picture of it. Okay, because once you draw a picture and identify which quadrant you're in, that forces your x to be positive or negative depending on which quadrant you're in. And there's a core concept that relates to it, and we'll talk about it. But kids, once I put the point 8, negative 6 down here and drew my triangle, was it easy to see again?
Yeah.
And it's really stuff you've done already, isn't it? Okay, so let's take this a step further. Questions so far? All right, Mike. Here's a big one. All right. Okay. This is about what? The unit circle. So the assumption is the radius is what value, kids? 1, you agree with that? Okay, the unit circle, x squared plus y squared equals 1, which has center where? 0, 0, and radius 1 is called the unit circle. The values of sine of theta and cosine theta are simply the y-coordinate and x-coordinate, respectively, of the point where the terminal side of theta intersects the unit circle. So in other words, the sine of theta, they're saying, is equal to, guys, this would be like a y value, vertical over a hypotenuse, y over r, but in a unit circle, what's the radius equal to? 1. So the sine of theta in a unit circle is simply which value?
1.
And the cosine of theta is equal to your x value over r, but r is what value again?
1.
Therefore, the cosine value in the unit circle would just be your what? Now guys, think about this. You're going to run into trig identities this year, and I'm going to show you this one a little early. Remember, we said the unit circle forms from x squared plus y squared is equal to what value?
1.
Okay, well what can I replace x with now? Cosine of what? What can I replace y with? One identity you're going to learn this year, and it's going to be very important, is this. We understand that this forms a unit circle, but the unit circle is based on sine and cosine values, okay? So one identity that's going to be really important this year is the following. If you ever see cosine squared of theta plus sine squared of theta anywhere, Same angle, betas are the same. That must equal what value?
1.
1. So if you walk into the ACT on your day of testing, and you see like, oh my gosh, this problem had this parson, it said sine squared 5x plus cosine squared 5x, that big problem that said solve it, don't let that intimidate you, because this is simply what value? 1. The 5x and the 5x are the same. You ever see sine squared plus cosine squared walking into the ACT someday? That value is automatically what? 1. Okay? Remember that. So let's take a look at what we've got here with this identity. So the unit circle, this only works on the unit circle when radius is what? 1. So let's see what happens here.
What would you do?
It says unit circle, uses unit circle. Okay, unit circle, oh my gosh.
I don't even know.
This is not a fun one. I don't know why they did this to you, but I'm going to do it anyway. Coordinate plane over here, friends.
That's what we have.
Oh, that's a straight line.
Yeah, it is.
Oh my goodness, all right, now you're calling me out. Is that more gooder?
Yeah.
All right, never mind.
Why does he cackle?
Because he said gooder, and gooder's not a word.
More gooder. It's more gooder. It's like a positive positive.
Yeah.
All right, then, never mind.
He's hiding right now.
You should have seen your face, Bailey. That was good. Initial side right here, right, friends? And you guys agree this is my 90-degree angle?
Yep.
Hey, here's the deal. How long is the radius of a 90-degree angle? So if I would rotate this angle around, kids, isn't my point going to end right here? What point is that going to end with if the radius is 1? Isn't that 1 unit up here then? So for this angle I'm talking about, kids, really, this point up here is really 0, comma what? Okay, so here's the situation. I'm just going to jot this down. For this point, for my terminal side on the unit circle, which is going to pass through this, okay, x is going to be what value? 0. X is going to equal 0. Y is going to equal what? 1. What's the radius going to equal, friends? Because it's a unit circle, radius has to be 1, right? Hey, so I'm going to go back to this. First of all, you agree that I've got this 90-degree angle in the right spot? Okay. We need to evaluate the what again, kids? Sine of theta. Okay? Cosine of theta. Oh, this is what I'm trying to get before prom, right here.
And he was thinking of it first.
Oh, I got it.
You chaperoning prom?
Look, those hip shoulder movements.
Carson, are you chaperoning prom?
I'm supposed to, but
You're going to do it.
listen, here's the deal. I'll be honest with you about chaperoning prom as a teacher. You guys put up with your teachers all the time. I don't think that when you have fun events, you should have to put up with this. That's how I feel about it.
Well, my mom and my teacher at the same time.
Yeah, well, that's a double whammy for you then, isn't it?
That really sucks.
And she gets to take my dad as her weekend.
I don't know. You guys want me to go or not?
Yeah.
I'm not boogieing. I'll tell you that much right now.
You gotta break.
Not in this day with all the phones. You guys would like make a ticky-tock-toe thing.
Probably, but it would be fun.
You think
It'd be
it'd funny?
good.
Yeah, I don't know about that. Alrighty, friends, let's talk.
It would do nothing but help you, Parson.
You think so?
Yeah. Yeah.
Well, is there money involved?
Yeah?
Well, then I'll think
If you
about
get
it.
famous on TikTok.
Yeah.
Alright, let's talk about this here. Let's go back to that core concept. I'm going to kind of write down by the sine right here. The sine was to say take y and divide it by the radius. The cosine was to say take x and divide it by the radius. And the tangent was like saying take your y value and divide it by the what? Okay, let's talk about this. Now again, things are kind of the same here, but the thing that really happens here, guys, is this. If this is going to be my central angle right here, do I really form a triangle here or not? Because the point that's not out here, the terminal side goes up here. Do I go left or right at all for a base of a triangle here? I don't. So this is an interesting one, okay? What's the y value for sine theta? Wouldn't this be 1 divided by 1?
Yeah.
Which is equal to what? So the sine of theta is going to be what value, kids? 1. Let's talk about cosecant then. What's the reciprocal of 1 over 1? So that must equal 1, right? Okay, then things get kind of interesting here.
0 divided 1. Yeah.
Okay, so how about the cosine?
0 divided
0 over what?
1.
Which force is what value?
0. I have no idea.
Okay.
Irrelevant.
Okay, but here's an interesting one. Suddenly we get to the secant of theta.
And it's 1 over 2.
This becomes 1 over 0. Now we've talked a million times in algebra, you can't have what in the denominator.
0.
So we say that this is what?
NA.
Not possible, or mathematically speaking, if I put a u there, what's that mean? Undefined.
Really?
Okay.
Okay. I use
All right, that's an interesting one, right? What's the definition of tangent?
y over 1 over. Oh no.
Which is what?
Icky. U.
Undefined again. Okay? Guys, you guys remember in rational functions when we said, ooh, the denominator is 0 here at this particular value of x or y? And we tried graphing those things. We said, we've got to put something here to show that that value can be used. You remember what those things were that we put in the graphs? Started with an A?
Angle.
Asymptotes, yeah.
Don't press
Okay.
asymptotes.
When you have trig functions that are undefined like this, and we'll look at this down the road, we're going to start looking at graphing some of this stuff right here. But if it's ever undefined at a certain angle, that graph is going to pertain to something that's discontinuous, so it's going to have some asymptotes, vertical or horizontal. Okay, and we've talked about those when relative to rational functions. Careful on the cotangent. Let's see, the tangent was 1 over 0, so the cotangent would be what?
0.
Which is what value?
0.
Okay. One thing I want to show you about these two right here. If you ever have one value be 0, then the other value is, I should say its reciprocal is going to be undefined. And if you ever get a situation where the value is undefined, then the reciprocal of undefined is really what? 0. So the question becomes, what's the reciprocal of 0? This could be on Who Wants to Be a Millionaire or something. This could be the big question. What's the reciprocal of 0?
Undefined.
Undefined. In math, what's the reciprocal of undefined?
0.
Weird, isn't it?
We're so smart.
I know. Oh, I love talking about this stuff. It just geeks me up. I love it. It's so exciting.
We can go.
I'm sorry. Okay, guys. I think you're gonna rock this right here. Finding a what, kids? Okay. My suggestion for you is the following. Okay, do we work better in degrees or do we work better in radians?
I like degrees.
We love degrees. Okay. Here's the deal. Okay. If you were gonna race, if you got a Corvette or a Beetle, the Corvette's probably gonna win, right? So take the Corvette. Yeah. Well, the Beetle could be like Kirby the Love Bug, right? Okay. All right. 220 degrees is our angle. We're trying to find a reference for this. Kids, tell me where 220 degrees will fall in the coordinate plane if I start rotating counterclockwise. How far have I gone?
90.
90?
180.
180?
Don't cross.
About there?
Yep.
Okay. So do you guys agree the reference angle it's going to form is going to be between the x-axis and here?
Yes.
Okay, well kids, think about this. If this is 180, how far past the x-axis did this terminal side get?
40.
So what's the reference angle for 220 degrees? Okay, this would be, in here, this angle right here, this angle would be, that's formed,
Oh.
this would be a 40-degree angle, right? Okay, and then 220 rotated around to here. So the reference angle for 220 is what? 40 degrees. Now here's the deal. If I said just graph a 40-degree angle, which quadrant is a 40-degree angle going to land in? 1, okay? We're going to talk about some things in terms of reference angles, but this is a huge concept to understand, all right? So the reference angle for 220 degrees is 40 degrees, okay? Now guys, I think the approach I'm going to take with radians right now, since radians are pretty new for us, I say let's probably turn that into what? Degrees. Now I want you to understand something. If they preface something by what's the radian, or I'm sorry, what's the reference angle in radians, they probably want a reference angle in what unit then? Okay, we're going to switch from radians to degrees to make this easier on us, but when I get a reference angle in degrees, we need to flip that back into what? Radians, because we started with what? All right, so help me out here. I've got this 15 pi over 6. I struggle with radians a little bit, maybe. 16, very good. Making sure you're paying attention, and you are. I love it. What do I have to multiply to turn this to degrees?
180.
180 over what?
5.
Okay, my little mathletes, help me out.
15 times 180.
Pi's cancel.
Whatever 15 times 180.
So somebody run 15 times 180 divided 16.
Does Parson not know it? Parson doesn't know it in his head. Slacking.
Well, it's probably 11 and a quarter, so it's probably, hey, let me try.
You got this.
Let me
Hey.
try. How about 168.75?
Yep. Oh my gosh.
What in the heck?
I know. You know why?
Can you remember?
Because trail mix is brain food.
Okay.
All right then.
You
See?
said it for breathe.
Okay, so here's the deal. 168.75. Which quadrant would that park you in, kids? Park you in quadrant 2, right?
No. I gave you food on Friday.
This is 180 right here.
Jefferson kids are like that. Yeah. That's what they eat. Yeah.
This angle is 168.75, right?
Correct. Okay.
So the reference angle would form with the x-axis that's over here on the negative side, and the terminal side right there. What's that angle going to be? Close. 11.25, right?
Yeah.
Okay, so this equals 11.25 degrees as my reference. Well, we better do what here, kids?
Change it back.
Change it back. So multiply it by pi over what? Okay, now this is where things might get a little tricky. And I'm going to go the other route with this too. You might see this in radians very well too. But kids, I'm going to leave the 11.25 over pi up here and then 180 down here. Problem is, I don't know how to reduce this.
Yeah, neither do I.
Okay? I see a 0.25 in here. Is that a problem?
Yeah.
Okay. One way to get around it is this. Move the decimal 2 to the right here. Call it 1,125. Pi over 18,000.
Oh, I have too many zeros on it.
Now, there are a lot of times like this in a problem like this, your reference angles are relative to either pi or 2 pi typically. Okay? Guys, here's the deal. You guys agree that from the other drawing I had the other day, 180 degrees is also the same as pi radians?
Yeah.
Okay, well we went 15/16 pi radians. So how many more 16ths would I have to get clear over here to pi radians? 1/16. Do this for me actually. Take 18,000 in your calculator.
Yeah.
See if 1125 might possibly go into that.
I don't think
18,000 divided 1125. 16.
so. Whoa.
This is actually the same as pi over what? Okay, so if you can think of it that way and say, well, the hard part for us is we don't quite know where 15 pi over 16 is going to land right now. Is that true?
Yeah.
Okay, maybe you do, but if you understand this is pi radians right here, like, ooh, I went 15/16 of the way. 8/16 would be half of the way up here, wouldn't it?
You need like 160.
So you'd have like 1/16 pi to go to get to that x-axis there.
Yeah.
Okay? My suggestion, I think turn it to degrees. Oh, and maybe I'm assuming, but is my assumption that you guys working in degrees, you more comfortable with degrees than you are radians right now?
Yep.
I would say turn stuff to degrees, do your work, and then if an answer starts out with radians, it probably wants an answer to end with what? Like we did right down here. Okay? Guys, what's the best way to define reference angles?
The distance between the x-axis and the end of, I don't
The
know.
terminal side, right?
Yes.
So it's the angle formed with the x-axis and the terminal side. And it's going to be something from what to what? 0 to 90. Okay? Kind of like my truck. 2.3 seconds. Yeah.
You just enough to set it.
Actually, it's my minivan we were talking about the other day.
The hell van. Yeah.
I think you should make that a class.
You think so?
Yeah.
That would be so fun.
It's the least you owe us for not teaching stats.
Maybe I'll have it by the last day of school and then I'll be blaring school's out for summer.
That would be pretty cool.
I better not do that.
I don't know. if
We
it's
want to
really
help
like-
decorate the van.
It'd be fun. Listen, I think with the van, there's a shop class application, there's an art class application, there can be an interior design application.
Personal finance.
Definitely science involved, and we're talking acceleration, right? Okay. All right. I want my hood to have like, you know, like how they used to have hood ornaments in some of the older cars.
Yeah.
I want like a big square root symbol on the front of my van coming down the road. Okay. Sound good?
I'm surprised there was a pie.
Oh, let's go with the pie symbol. Why not? Because Pie Day is Sunday, guys.
Really?
All right. Yep. Okay, guys. We're getting close on time. You know, here's this last one I really want to talk about. I don't think we're going to get all the way through this here. I want to get through example 4. We're going to call it mid. Is that okay, kids? Okay. This is going to be a super important chart for you guys to have. Okay.
No. Tuesday. Friday.
All right. You're going to refer to this chart a lot.
Really?
Yes. What this chart is telling me is the following, kids. In quadrant number 1, all 6 trig functions are what kind of values? Positive. In quadrant 2, what are my 2 positive trig values? The sine is positive in both of these because the y value is up here. The sine is like the y value. Is the y value above the origin or below the origin? Okay. The cosine's positive over here because we're going to the right, like the x-axis, right? Okay. Now, kids, one thing you probably don't know yet, but the tangent is going to be a sine divided by a cosine, or a positive divided by a, which is a. Okay, so over here, the sine goes up, the cosine goes negative. That's why the cosine is negative. And if tangent's really a sine over a cosine, what's a positive divided by a negative? And that's why. Okay. Over here on the left, if I go left and down, what's true of your x and y values?
Both negative.
They're both negative. What's a negative divided by a negative?
Awesome.
That's why the tangent and cotangent are positive down there. Is this making sense?
Yeah.
Okay, over here, if I go right, is the x value positive or negative?
Positive.
That's why the cosine is what?
Positive.
If I go down here in the 4th quadrant, that's like a sine value, which is, and then what's a negative divided by a positive? Okay? So the chart kind of makes sense there.
Yep.
Here's where things get interesting. They ask you guys to evaluate some of this stuff. Okay? Now I'm not going to get too picky about this, but they say evaluate the cotangent of what? Negative 210 degrees. Okay? I can do the tangent of negative 210 degrees in my calculator and then do what if I want to? Flip it. Okay? What they want you to do though is use what type of angles to make this work. Okay, so let's get a little sketch of this and see what the heck is going on here. First of all, if it's negative 210 degrees that we're concerned about, is this going to be a clockwise angle or a counterclockwise angle? Clockwise angle. So here's 90. Here is 180. How much further do I have to go? 30 more, right? So isn't negative 210 going to end about here, kids? Okay, so let's see. What's your reference angle going to be right in here? 30 degrees. So here's the deal. The reference angle for this is going to come from, I'm going to write this down here. The reference angle must be 30 degrees. Okay? So here's how we're going to handle this. I'm going to rewrite this cotangent, negative 210, as the cotangent of what reference angle, kids? 30 degrees. Now let me show you what the heck is happening here. Guys, go back up to your chart.
Yeah.
Let's talk about that negative 210 degree angle here. This negative 210 degree angle landed in which quadrant, kids? Second. If you look at the cotangent in the 2nd quadrant, that answer is going to be what type of an answer? But we're referencing what angle here? And the cotangent in the first quadrant, 30 degrees, is a what? So the only way I can make this match this is to put what out in front of the cotangent? A negative sign. So kids, when you're checking, where was I, where am I going? If the signs switch, what do you have to put in front of this when you rewrite it? Negative. What if this would have said, not cotangent negative 210, but sine of negative 210? In the second quadrant, sine is what? And the reference angle in the first quadrant would be what? Therefore, would I have had to put a negative sign out here?
No.
Because they would have been a match. Okay? So here's where things get interesting. All right? Kids, you know we're talking about what angle here? 30 degrees. I got a thing for you. You guys remember that little chart in the first section that we first started talking about? That little special angle chart?
Yep.
Let me go there. Hang on a second. I'm going to jump into this. So way down here, online calculators and resources, it is the special angles value. What angle am I talking about? Okay, there's 30 degrees right here. I want the what? Cotangent. What's that chart say right there? Root 3. Okay, so the cotangent would be root 3, but it's going to be negative root 3 here.
Wow. Flex.
Okay.
I don't like
Bodybuilder.
Isn't this cool?
Sure.
I'm not sure you all share the same excitement I have for it, but this is pretty cool. Let's try another one. Oh, goodness gracious me. There's that radian thing again. Okay. Let's make this the last one and we'll call it a day. Deal?
Yep.
Let's turn this cosine of 10 pi over 4 into something. 10 pi over 4, friends. What are we going to multiply by first? All right, so I'm listening.
Cross, cross.
Yes? Is that 450 when I'm done?
Yep.
Okay. You trust my math?
I trust my math.
All right, so talk to me, friends. We're rotating how many degrees? Okay, so here is 360. How much more? Oh my goodness. We end up right here, don't we?
That's crazy.
What's the reference angle going to be in the first quadrant then if we end up here?
0.
Not 0. It would actually be
90.
90. So the reference angle for this is going to be... You all agree with that? Now here's the deal. This is a quadrantal angle. So I'm not quite sure how to handle this one, but by unit circle we had some rules, didn't we? See, the cosine of 450 would end up in the same exact spot as 90, right?
Yeah.
So it should be exactly the same, shouldn't it? Can I multiply this by pi over 180 now?
Yeah.
Hey. This is going to be the same as then the cosine of not that, but pi over what, friends? Pi over 2, right? Okay, so I go to my chart and I look up cosine of pi over 2. Hopefully pi over 2 is a nice one here. We better check though. Does pi over 2 radians show up right here?
Yeah.
In the radians column, pi over 2, what is the cosine there, kids? 0.
That means 0
Okay, so yeah, that would mean the secant would be undefined there, wouldn't it? Okay. So, where is that at? Yep, the cosine of pi over 2 would equal what value again?
0.
Or again, it's just the x value. How far left or right from the origin do I go to get to this point up here on the unit circle? 0 units. Okay. All right, kids, I'm going to stop there. Listen, I hope you guys have a great break. It's been a strange year this year. Find some time to relax, okay?